Namaste and welcome to CADEC learning video on Formulator with Conveyor example. In this sketch, we can see a roller conveyor. It shows some components and some design variables. In this video, we'll define only variable calculations and test them. We'll not create any model at this stage. We'll use CADEC variable table and rules. I'll start with a blank assembly. I'll create a new folder. Uh, let's say my conveyor. Let's say the assembly name is simple conveyor. I'll crawl this. So it will create a new rule database. The rule database will be saved in the same folder. Now I'll click on size variables where we'll define all design variables and their calculations and validations. In this video, we'll see variable table and rules. So I'll just go on creating some variables. For example, let's say conveyor length, conveyor width, conveyor height, conveyor height to be specified in millimeter is what I will specify. Then component to be conveyed, the length of that component. Weight in kg. I filled all the variables and their values. You can see that roller dimensions are there, then leg dimensions are there. I've created some, defined some validations like range. This conveyor height should be between 500 and 800. Conveyor length should be between 300 and 600 and so on. So for some of the components, I have specified validation as fixed. That means it will have some fixed values to be chosen from. And then some of these expressions are like this. Channel height is fixed into bracket channel size. That means the channel size can be chosen from some fixed values, and then there will be a lookup table based on channel size and channel height. Similarly, uh, okay, some of the calculation formulae are specified. For example, the length is equal to speed into time multiplied by 1000 to make it a millimeter value. Then conveyor width is equal to component width plus 100. Roller diameter depends on the conveyor weight, so it is fixed based on conveyor weight. Then roller length is 5 less than the conveyor. Sorry, this is wrong. Conveyor length minus 5 Sorry, conveyor width minus 5 Then to calculate roller number, I have used a logic that each component will be resting on minimum 3 rollers. Uh, for the component, I have specified, I have taken some design variables called component overhang. So the component may not be resting on the flat, because at the end there can be some overhang. So this is compound overhang, and the rollers may not start exactly from the end of the channel. There will be some start gap and end gap. So these variables are also used in my calculations. So if we see the roller number, so it is round up of l- num rollers numerator divided by num rollers denominator, comma 0. That means I want to round up to the nearest upper integer and plus 1. Now this numerator is the effective length of the conveyor for the rollers. That is conveyor length minus start gap and end gap. Now this start gap and end gap, I have assumed something, but if the component has more overhang or less overhang, then the user can always override. I have created three variables with underscore o, that is overriding variables. So if the for example, if the start gap value is not given, then it will take the default value of 50. But if the user specifies some values, then it will take that value. So I have created overrides for start gap, end gap, and component overhang also. So with this kind of overriding, we can make the design calculations in CADEC uh, two-step calculations. Otherwise, most of the calculations are one step. Similarly, so I have calculated the roller number first, so that is numerator and denominator, and then I have calculated roller number as round up of numerator divided by denominator rounded up plus 1, and then the roller pitch is calculated as roller numerator, which is the effective length of the conveyor, divided by roller number minus 1. And similarly leg pitch, I want the leg pitch to be 1500, but if I take exactly as 1500, then the roller number may be fraction. So I have calculated the roller number first, sorry, leg number first. So leg number is round up of conveyor length, total conveyor length calculated, divide by 1500, and then I have rounded up to the nearest higher uh, number. So this, it should be plus 1. And the leg pitch is equal to conveyor length minus leg num minus 1. So this is how I have defined all the variables. Will the range is defined here itself. The fixed details we'll have to specify in lookup table. So we'll see that shortly. So I'll first save this. So it says that leg number. Okay. So now leg number, there is a error, it says. I'll just see where is leg number. So while saving, CADEC checks all the syntaxes, all the variables. So leg number has a error. Let's see what is the error in leg number. Okay. So leg number is used here, but it is not defined anywhere here. Okay. So that means I have to. So leg pitch. Where is leg number? Okay, so it has not saved that leg number. I'll have to define the leg number again. So leg number equal to I'll use it this way. So leg number equal to conveyor length divided by 1500, and I'll make it round up, comma 0 and plus 1. So now I have defined the leg number, and the leg number is used in leg pitch. So okay, leg height also I need to calculate. So leg height is equal to leg height equal to conveyor height minus channel height, uh, channel height that should be channel height by 2 minus roller diameter divided by 2, because I am taking the uh, conveyor height as the top of the roller. So half the roller and half the channel should be reduced from that to get the leg height. Achha, okay. I didn't save the last one. Leg number is saved. I didn't add the leg height. Conveyor height minus channel height by 2 minus roller diameter by 2. Uh, by the BODMAS rule, it will first calculate the division and then subtract. So I don't need to add any brackets. I will add this. I'll save. So now it has calculated, it has defined all the variables. Let us now define the rules. So I'll go to calculation rules and I'll go to size variable. So wherever I have defined fixed, those variables are seen here. So first of all, component weight kg. So I'll specify that the user can specify component weight of 5 kg. Let's say 7.5 kg, 10 kg, 12 kg, and 15 kg. And for that, I'll specify the roller diameter will be for 5 kg component. I'll specify the roller. This of course should come from my empirical uh, design values. So for 5 kg, the roller diameter should be 30 diameter. So 7.5, I'll take 40. For 10, I'll take 45. For 12, I'll take 60. For 15, I'll take 70. Okay, I'll save this. So this lookup is saved. Then second lookup is conveyor speed meter per minute. So this doesn't have any dependent value, but I'll have to specify some speed values. So 1 meter per minute, 1.5 meter per minute, and 2 meter per minute. I will save this. Then travel time in minutes. Again, it doesn't have any dependent values, but I'll say 6 minutes, 8 minutes, 10 minutes, 20 minutes, let's say 15 minutes and 20 minutes. These are the travel times. This travel time means the suppose this conveyor is used in some process. The process time uh, for which the component should be on the conveyor is specified by the process designer. So the conveyor length is calculated based on this process time and the uh, conveyor speed. So I'll save this, and then channel size. I'll specify the channel sizes as ISMC 100, ISMC 125, ISMC 150, and for that I'll have channel height as 100, 125, and 150. Okay, so all my uh, lookups are defined now. So uh, the design calculation is defined. Now let us check the design calculation. So I'll go to auto create designs. I'll choose simple conveyor and I'll specify some layout ID. Let's say my conveyor 001. Then I'll specify some conveyor height. Let's say 700. Then conveyor length in millimeter, component length in millimeter. Let me say 400. Component width is, let's say, 500. Then component weight I'll have to choose, let's say, 5 kg. Conveyor speed I'll choose 1. Travel time in minutes I'll choose 8 minutes. Component overhang, these things I'll not give, so let it take the default values. Channel size I'll choose 100. Let me now calculate the values. So it says that these three are uh, not specified, so it will take them at 0 and calculate the values now. So I get the conveyor length as 800, 8000. Then roller length as 895, leg pitch as 1333, then roller number as, where is roller number, as 54, roller pitch as 149, and so let me specify some other values also. Let's say this is 900. So it says that it should be between 500 and 800. So let me take 800. Let me choose this as 10 kg. Let me take this as 150. Let the travel time be 10 minutes and component width as 600. And let me calculate again. So now the conveyor length is 10 meters. The leg pitch is 1428. Number of rollers are 67. Roller pitch is 150, and so on. So this is how we can define the design calculations and test them. Thank you.